left off. When the bell rang yesterday, I said I'm just going to continue today. There was no homework. Right, let me see this from yesterday. Go in your notebook to what I did yesterday. I showed you a couple problems where you had to just get the number on the other side, take the square root, and I showed you one like this. I just recopied it. Look up here. This is the last thing I did yesterday. Get a zero, factor it, set them to zero, get your answers. Now, today, I got two things. All right, fellas, here's the deal. I started to tell you this yesterday. I'm not going to be here tomorrow. So the deal for tomorrow is this. The homework that I'm going to give you today, when I finish this, isn't due till Monday. See that? You'll take a picture of that later in class, not right now. I'm going to finish, I started yesterday and I'm going to finish today. Then I'm going to show you one more thing today, and that's going to be your homework in class tomorrow. Now, I've already left all the notes with the substitutes, so just no problems tomorrow, please. Just do what you're supposed to do. All right, I don't want to have to come back and hear that there were issues, all right? Just do what you're supposed to do. The homework that you're going to have tomorrow is going to be 9 problems. You're going to do it in class, turn it in, then you can take your iPad out, because it shouldn't take you the whole period. I'll show you what you're going to do tomorrow here in a few minutes here. All right, so in your notebook, put these two problems next to each other right now. Right there, that A and B problem that are there. Put them next to each other. And remember, this is still solving trig equations. Put problem A and problem B next to each other. Now, these are all quadratic, as you know. Quadratic means there's something squared in the problem. The paper that you gave me the other day, remember you all got it done in class? You all had it on my desk before the period ended. Those were all linear. I'll give you all your papers back Monday when I get back. Now, I'm not going to write this on the board. Just listen to what I'm going to say. First, freshman algebra. Do you see what I've been doing? I've been showing you freshman algebra, then I show you the same thing with the trig. If I told you to solve this, somebody, what would you do? Solve this. Notice there's already a 0 on one side. So it's like ready to go. Wow. People, how would you solve that for x? Jack? How? What kind of factoring? Say it? Common factor, that's right. In your notebook, off to the side, write that down, that little equation. That off to the side, that little equation there, write that down. What's the GCF, Ethan?
X.
What's left?
2x minus x.
No.
Minus 1.
And then, remember yesterday? Look, remember when I did this one yesterday? I factored it, and then I set the factors to 0. Same thing here. Set the factors to 0. That's already done. And this is just variables left, constant right. So that's a pretty simple problem from freshman algebra. Now, today, I'm not going to write this on the board, just listen. When 2 or more trig functions occur in the same problem. See, this one has 2 trig functions in it. This one doesn't, because this one is like this, only it has trig. Collect all terms to one side and try to separate them by factoring. What would you do in this one right here? Guys, this is just like this, but there's trig in it. That's what I've been trying to show you. It's the same as freshman algebra, but you got trig in it. David.
If you pull out a
Cosine of x is common, right? So factor out cosine of x. Now somebody, tell me what's left when you pull that out. When you pull out cosine of x times what would give me that? Just like you did in 9th grade. Chris?
2 cosine of x minus radical 3.
Okay, now what are you gonna do? Fellas, this is just like this. It's just tricking. It's the only thing different. No,
Set them equal to 0.
set them equal to 0. Go ahead and do that. Cosine of x equals 0, or 2 cosine of x minus the square root of 3 equals 0. Now, this one's like ready to go here. So I guess the question is, okay, what are the angles? Look, I'm just gonna keep saying this. You're probably tired of hearing it. You know, I gave you that last test back. It was at your seat when you walked in. A lot of your grades would have been way, way better if in the first 2 parts of the test you knew all your special angles. Got to know your angles. The cosine of what angle is a 0? Now, what are you thinking of in your mind? That's that unit circle stuff, right? The cosine of what angles is a 0? Andrew, I'm right here. See where we're at, right here in your notebook. You guys should know these faster than you do. Rob, 90 degrees. There's another place too. See, there's more than one answer. The cosine of 90 is 0 because the point's 0, 1. It's the x, right? Rob? 270 is 0, negative 1. It's also a 0. So here, x is 90 degrees, comma, 270 degrees. Now, do you see that this is linear now? So this is just variables left, constants right. So 2 cosine of x, put the square root of 3 on the other side. Cosine of x, divide by 2. Here you go again. What's the angle for cosine? That's radical 3 over 2. I mean, it's the same angles coming up all the time. It never changes. Rob?
30.
So what quadrants could this answer be in?
1 and 4.
1 and 4. So 30, or what is it in the fourth with the 30? Max?
230.
330. Does somebody have a question? Okay, now, what do you suppose would be your first step in problem B? Somebody? It's going to be simple. What do you suppose you would want to do first? Freshman algebra. Freshman algebra. Jack? Get a 0 on one side. That's right. So this is going to come over here. So in your notebook, go secant squared of theta, tan of theta. Slide this over to the left, minus 2 tan of theta. Okay, now, same concept. What am I going to do? Factor it now. There's only one way you can factor that. Quinn?
Is it tan of theta?
Tan of theta is common factor, right? Okay, factor out tan of theta. What's left when you pull out tan of theta? Huh? What's left then? Somebody? Max?
Secant squared x minus tan x.
Okay, these are thetas here.
Theta.
Secant squared theta minus,
Tan theta.
no, tan theta came out.
Oh, just theta.
No,
Or,
look. Minus,
minus 2.
minus 2. Now what? Watch this. Now what? Two factors there. What are you going to do with your 2 factors? Ethan? Set them to 0. Tan of theta equals 0. Or secant secant squared of theta minus 2 equals 0. Okay, now look at this one right here. Tan of theta equals 0. Where you at? This is also unit circle because it's a 0. Now what's the definition for tan? Y over x, right? If you have to look on your chart, that nice chart I printed up for you, should have it there in your notebook probably. The tan of what angles is a 0? Rob? 0 or 180? Theta, 0 or 180. Now, didn't I show you how to do these kind yesterday? Look at this. You guys that weren't here yesterday, you got that stuff, right? It was sent to you. Okay. No linear term. So how do you do these kinds? The first thing I showed you yesterday. There's no linear term here. So what do you do? You guys forget stuff so fast. How are you going to solve this one right here? Jack? Put the 2 on the other side. And then what are you going to do to both sides? I did this yesterday with you. This is that square root principle. Noah?
Take square root of both sides.
You can take the square root of both sides. Isn't this secant of theta equals plus or minus the square root of 2? Now, look on your chart if you have to. What's the angle associated with secant for radical 2? What's the angle that's associated with secant for the square root of 2? David?
45 and 315.
Now, hold on here. This is when it's plus or minus, that means you're going to have how many answers?
So 45.
All the way around, right? 45 degrees, second quadrant, 135 degrees, 225, 315. Who has a question? I got one more thing to show you. Now, this is what you're going to be doing in class tomorrow. Now mark this down. I'll review this with you right now, because you all did this. You all covered this. Not only did you cover it in freshman algebra, you probably used it in geometry too. This would be wonderful if one of you could just recite it for me. It's a formula. It's called the quadratic formula. I have to show you how to use this because when we get back to school next Monday, what I'm going to show you, you have to know how to do this. So we're going to take care of this right now. This would be great if you could, like, just off the top of your head, give it to me. You all used it. All of you. Even you, I'll bet. That you did. Can you tell me? That's okay. Go ahead, Jack. Shh. Say it again. Could you close that door? Joe, could you close that door? Sorry, Jack. Go again.
Opposite of b equals opposite of b plus or minus the square root of b squared minus 4ac all over 2.
Beautiful. Now mark this down, because that should look very familiar. Now that it's in front of your face. Now, write down this, and then right next to it, write down this. Look at these two equations. I want you to solve these two equations using that formula, quadratic formula. Very powerful formula in algebra. You're going to need this next Monday when I get back for what I'm going to show you. Now, there's one little catch. You cannot use this. Listen to what I'm going to say here. You cannot use this unless the problem looks like that, first of all. gotta look like this. See, now this one already is, but this one isn't. That just means you gotta get everything on one side. So you remember, the squared one, you always want positive. So slide this over. Now, I'm thinking you gotta remember this. Somebody, all you do is what here? It's really not that hard. This is what you're gonna do in class tomorrow. The teacher's gonna give you the problems. There's only gonna be 9 of them. You don't know what to tell me now, because we're all kind of set up here. I want you to solve them 2 equations using that. All you gotta do is, really, it's that simple. All you gotta do is add them. Put them all in. Now, when I say put them all in, look. There's A, there's B, there's C. So in this problem, A is 2, B is 6, C is 1. You with me now? Just put them in. A is 3, B is -10, watch your signs. C is 8. So in your notebook here, now let me do this first one. Opposite of B, look, opposite of B. B is 6, opposite B is -6. I'm just plugging them in. Plus or minus, square root of. Somebody, what would B squared be? Guys, all I'm doing is putting the numbers in. Just plug them in, and then I gotta reduce it. Ethan.
36.
Now watch this. -4 times the A, which is a 2, times the C, which is a 1. Look how I'm doing this. This is what I want you to do. And what would be on the bottom? 2 times the A. So what's the number gonna be down there? Joe? 4. All right, come over here. Do the same thing. X equals, all right, one of you, tell me what to write down. Plug them in. Just plug them in. It's that simple. Just plug them in. Quinn, opposite of B.
100.
Opposite of B. Just opposite of B.
Oh, 10, my bad.
Okay, B's -10, so
Yeah.
opposite of B is 10. Plus or minus the square root of B squared.
100.
100, and then just do this, -4 times the A, which is a 3, times the C, which is an 8. All over 2 times the A
6.
would be a 6. Now, this ain't done yet. What do you gotta do now? What's the next thing you gotta do here? David?
You have to find what's in the square root.
You gotta get that number in there. So -6 plus or minus, look what I'm doing here. You do the same. 10 plus or minus, look what I'm doing here. You do the same. Now, watch this. You see these 3 numbers here? You gotta times these first. You don't do anything with that 36 yet. Isn't this 36 minus 8? What's that?
28.
-6 plus or minus, now you guys are pros at reducing radicals by now, you've been doing it the whole year. What's the square root of 28? Break it down, pull out the perfect square. You've been doing that all year. Ethan?
2 radical 7.
Yeah, 4 times 7, so that's 2 radical 7. Now watch this, one more little catch here. That's not done yet.